G'day guys, how's it going? So in this video, we're going to kind of look at a continuation of the previous video where everything was all theoretical when we're talking about ownership. What I'm going to do here is I'm going to take you through basically a simple program and how we handle ownership as the program is executing, right? So we'll talk about when a variable is declared, things are created, when they're dropped, things of that nature, right? So here's the program I got. I've got a main function. We've got some variables that are local to the main function. Then I've got a block, and that has two variables. And then we're printing some stuff out, so on and so forth, right? So it's a pretty simple program. It's just doing a lot of printing based on scopes. If you looked at my scopes video, this would look very similar to that, okay? So let's think about how things are done for each line of code in this main function. So we know about ownership and we know that a variable is the owner of a piece of data, right? So already from line 2, we can say that X is the owner of the data with a value of 1. So in this situation, X is pointing to a piece of data on the stack that has a value of 1. Okay, that's essentially what I'm trying to say there. Same with Y. Y is the owner of the data with a value of 2. And then we have this string, right? So I haven't shown you how to create a string yet, but essentially the way you can do it in a cheap way is to go string from with these two colons and then in parentheses, just a piece of text, right? In double quotes. This is what we call a string, right? Now we'll get into it a little bit more later. Whoops. We'll get into a little bit more later what a string is and what it does and how you can use it and how you can manipulate it, things of that nature. Just know this given situation that some string is the owner of the pointer that points to the text on the heap. All right, so keep in mind this is the text that will be sitting on the heap. So the owner, which is in this case some string, owns the pointer on the stack to this piece of data. Okay, so that's the important thing to understand there. So not only that, we can write here at this point in time, the data value of 1 is stored in the stack. Therefore, it's already created. Cool. So that's the same with the one below, even the one below that, right? So we can say 2 is stored on the stack. And then lastly, you get the picture, right? You get the idea. So this would already be stored on the heap, and the pointer to it will be allocated to that owner of that variable there, right? So then we can go through the process of going to the next print line, and we go, okay, we are fetching the value of 1 from X on the stack. So essentially, we do a stack lookup for X. We go, okay, what's the value of that? Well, we know it's also on the stack. Therefore, it's going to be a value of 1 because we stored it up here. Same as Y. We are fetching it, knowing full well that we can look up Y and get the value of 2. Okay. And then here we are fetching the text shown on line 4, right? From the pointer, sorry, let's say it again. On line 4, by first locating the pointer on the stack for variable some string, and I should bring that down to the next line just so we stay together. In fact, what I'll do is I'll bring that under there, and then we'll say once the pointer is found, we look into the heap to get the actual text. Cool. So that's what's going on with that line. And then we finally hit this block, right? So now we're in a new scope. We're in a new block scope. So now we know in this case, Z is the owner of data with a value of 3. All right. At this point in the block, the data value of 3 is stored on the stack. Therefore, it is already created. Cool. And I think you get the gist, right? So we can do the same for the next line for in the inner block. So this it'll say inner block string is the owner of the pointer, points to the text on the heap. The text below, not below. Then we're printing it all out. I'm not going to continue to repeat this, but eventually what's going to happen is you're going to hit this line here, right? So the curly brace below ends the scope for X, for Z and for inner block string. Okay. As a result, the Z entry and inner block entry is popped or is removed from the stack frame, and the I32 destructor is called to clear the value 3 on the stack as well. I should put the Z entry is removed from the stack. The inner block string is removed from the stack as well. And the pointer is also removed. When this happens, the string at the address is cleaned up / dropped by calling the string types destructor. So essentially, when we hit a right curly brace, we are going to remove all entries associated with this specific block. So that and that will get removed from the stack, and any data associated with it will be basically cleaned up. And it's done by using that data types destructor. Okay, that's the important thing to understand there. Now, that explains at this point, we can't refer to Z or inner block string, not just because of availability. Availability, but primarily because the data has already been cleaned up and the variables have been removed from the stack. So that is the primary reason why we can't refer to anything outside of a block scope, right? Because it's no longer there. Essentially, that's the reason. Right? So in this case, Z and inner block string are no longer there. And that is why at compile time, the compiler goes, you're trying to refer something outside of the scope. That is exactly why. Because they're not available to you anymore based on how Rust cleans up its resources, right? It says, nah, once you leave this block, this is no longer important to us. That's what you've told us by declaring the variable inside the block. You're saying once it leaves the block, you don't care about it anymore, which is why you can't refer to it on the outside. However, you can still refer to X, Y, and some string, but then obviously the process is going to repeat this same stuff that we just did here for Z and in the block. Oh, sorry, this bit here. The same process is going to happen for X, Y, and some string. And then by the end of the program, all variables will be popped off or deallocated, and the data will be cleaned up. And then obviously once that's done, main will get popped off the stack. Cool. So this was just a little mini exercise, I guess, just to get you to understand and visualize when you're looking at code exactly what's going on based on what we've learned in the last 3 videos. So that's all I'm going to have for this video. In the next video, we're going to start talking about changing ownership, all right, and how that works in Rust. So I'll see you all then.